Good afternoon, ladies and gentlemen. Good morning if you're in the Americas, and good evening if in Singapore and beyond. And welcome to this non-partisan, neutrally placed discussion on pumping systems. My name is Surendra Balakrishnan, and I'm the co-founder and editorial director of CPI Industry. We have gathered here to look at the evolving role of pumps in the context of multiple applications in district cooling plants, CHP, waste to energy, power generation, and in medium to large HVAC systems in hotels, malls, airports, and residential clusters. This webinar, sponsored by Proleed, is being attended by delegates from over 15 countries. And I'm pleased to inform that the CPI Industry team of journalists are taking notes in the background for a detailed post-event report of this webinar for widespread circulation to our entire database of readers in the Middle East region and elsewhere. This is a tradition that we follow at CPI Industry. And with that, we shall commence the plenary discussion, which, if I may add, has an inspiring and diverse lineup of speakers with considerable expertise and experience. They are, in alphabetical order, Nimal Amukotuwa. Nimal is an independent building services consultant with a passion for designing energy efficient systems. He's been in this field since 1970 as a refrigeration and air conditioning engineer. Thereafter, he moved to building services. Within a few years, he switched to maintenance, and years later to design. So we are likely to get a maintenance perspective from him as well, which is, I believe, fantastic. Welcome to the webinar, Nimal.
Thank
The
you.
next panelist is Anantharaman Kanagaraman. Anantharaman is a design lead MEP at SSH. He has over 20 years of experience in the MEP field. He has successfully completed major projects in the GCC region, ranging from hospitals, residential buildings, educational facilities, and hospitality and sports complex related projects. He has extensive experience in both air-cooled and water-cooled chiller plant design involving large network of chilled water pumping. Welcome, Anantharaman. The next panelist is Ibrahim Hisham Hassanein. Ibrahim is a mechanical engineer specialized in HVAC, district cooling plants, and related infrastructure networks, from system design to life cycle costs and from construction supervision to management. His specialties include piping stress and surge analysis, hydraulic modeling, CFD, and smoke management. Quite a diverse experience base there. Welcome, Ibrahim. The next panelist is Mohammed R. Zakaria. Zakaria is the chief consultant of Protect Division of Suhaimi Design in Saudi Arabia. He is a specialist in HVAC utility systems, control systems, and commissioning process. He has wide experience in Saudi Arabia with clients including Saudi Aramco, SABIC, SEC, and the Royal Commission. Zakaria has worked in various projects including district cooling, healthcare facilities, plant support facilities, in-plant buildings, industrial projects, laboratories, universities, office buildings, and commercial and residential facilities. Again, a very diverse experience base. Welcome, Zakaria. The next panelist is Kandasamy Anbalagan. Anbalagan is managing partner at Proleed Engineering Consultants. He is a mechanical engineer with over 30 years of experience, of which 25 years have been in the Middle East. He has worked with leading industry experts, including Atkins, Arab Tech, and Mario Associates, and has been part of many prestigious projects. At Proleed, he leads a team of over 35 engineers in Dubai and Chennai, and with operations in the UAE, Oman, Belarus, Kosovo, and India. Welcome, Anbu. The next panelist is Prabhakar Nayak. Prabhakar is a Managing Director of Vastu and Engineering Services. He's a mechanical engineer with more than 36 years of versatile GCC region experience in design, site supervision, and project management of building services and infrastructure works, with specialization in refrigeration and HVAC, including district cooling. Welcome on board, Prabhakar. The next panelist is Shekhar Reddy. Shekhar is the Managing Director of LED Ganda. He has experience in driving process, quality, and client service improvements while building partnerships with key business decision makers. He is known for building and motivating cross-functional teams that exceed corporate expectations. He has rich contracting experience and has completed projects worth over 3.5 billion dirhams, including in district cooling. So considerable experience there. Welcome, Shekhar. The next panelist is Hassan Yunus. Hassan is President of the ASHRAE Falcon Chapter and Director and co-founder at Griffin, which specializes in sustainable design, building energy efficiency, and district cooling. He is an ASHRAE Region at Large lecturer and ASHRAE trainer at the Society's Global Training Center, a certified trainer by the Association of Energy Engineers for the CEM course, and an appointed consultant for the ASHRAE 62.1 standard. Hassan is also on the boards of governors of the local chapters of ASHRAE and SIPSI. We appreciate your participation, Hassan. And rounding up the list of panelists is Sulaiman Dahabra. Sulaiman is Senior Operation Manager at Proleed. He is responsible for more than 70 district cooling plants with about 1 million refrigerated tons of installed capacity in the UAE and Bahrain. He also heads the Excellence Operations Department at Proleed, which is responsible for ensuring that the district cooling plants are performing to their optimum efficiency. He has been working in Proleed for over 22 years and has been responsible for many implementations in district cooling schemes, which were the key factors of plant efficiency. Welcome, Sulaiman. Good to have you on board. So welcome once again to all the panelists. And with that, let's plunge into the topics we have earmarked for discussion today. And as for those of you that have registered as delegates, we encourage you, we urge you to ask questions. So please feel free to post as many questions as you wish. And we shall be asking them either intermittently or towards the end of the plenary discussion at one go. Now, the overarching theme of this webinar is on extracting greater performance from pumping systems. With that in mind, the first question is, given the progress, the tremendous progress we have achieved in improving energy efficiency of pumping systems, how much more can we extract from them in terms of energy efficiency? For instance, how much further could we possibly improve the design of, say, impellers and other internal components? Who would like to take that? Could I have Zakaria start off the discussion on that?
Hello, thanks for having me in this great webinar. I'm really pleased to be participating in this with so many panelists having vast experience and background. The first point that I would like to say is in terms of getting maximum efficiency from the pumping system. The most important focus is already there is big improvement in efficiency of pumping design in terms of pump components and design of impellers and things like that. But in terms of operation, are we really operating the pump in its best operating point? That is probably the most important problem. If we analyze many of the projects that that is currently operational, the pumps are not operating in the best efficiency point or within the preferable operating rate. So if the operating point of the pump is shifted left of the best operating point much lower, when the selection is a mismatch with respect to system performance, then even though the pump can in reality can deliver much higher efficiency, we are only extracting very low efficient operation from the pump because of mismatch of pumping performance with respect to system performance. So if greater importance is given to operating the pump at the best efficiency point in almost all ranges of operation, if it has multiple pumps, also trying to operate multiple pumps in its best, closer to best efficiency point. If it is a variable volume pumping system, again, the number of pumps as well as the speed of pump to be appropriately, selected so that it is operating at the most energy efficient point, so that with the current pumping, available design itself, we can extract a lot of energy efficient operation and energy benefit from the pumping system.
Okay, so you're saying it's down to the personnel that are operating. I'd like to hear from Sulaiman, if you could give us a district cooling utility perspective on this, on the progress we have made in terms of being able to manufacture the best-in-class energy efficiency of pumps, and how that's translated when it comes to operations. Sulaiman, would you like to comment? I think you're on mute, Sulaiman.
Yeah. How are you? Good afternoon or good morning for anybody. It's in other region. It is my pleasure to contribute in this webinar and to discuss about the efficiency of the pump. From the point of view of the district cooling, the pumping, what my colleague here already explained that very important, all the operators should understand what is the best efficiency point to keep the pump running, especially when you have a pump in parallel. We need to run them all in the same best efficiency point, especially also if we have a VFD system. The operator, he should understand hydraulic, where is the index point of the network, to select it, identify it and select it, and keep this pump running based on the index point requirement to meet the demand of the chill water for all the client with minimum power consumption on the motor. The index point, it is very important to the pump as a lead to control the speed. And for that, also, we need to use the innovation, which is the control system as an PNID tuning to avoid the pump ramping very fast and reducing very fast. This one to maintain the stability of the operation of the network and maintain the proper flow for the entire network. Now the operator, how he can identify which one it is the index point. That means for me, it is the farthest point in the network, or the highest point, or it is the highest capacity in the network. He can select this is as an index point to lead the pump in optimum point and always running in more efficient.
Okay, thank you. I'd like to bring more consultants into the discussion. Would Hassan like to comment on this, please? Prabhakar, I'll come to you next.
Yeah.
Well, Hassan?
Hello, everyone. Yes. Thanks for inviting me to this webinar. First, we need to look at why do we need pumping? So what is the purpose of having the pump? We're trying to move energy from, most probably when you're talking about HVAC, trying to move energy from one place to the other. So from a design point of view now, the way to go, or let's say at least actually what they're promoting, is to having a higher delta T, going even beyond the 9 degrees C that we use for district cooling to maybe 10 or 11. So first of all, try to reduce the amount of water that is required to be transported. From the pump's point of view, in terms of impellers and design, I think we got to a really good place. It's not like we have a lot of inefficiency happening there, just like everyone mentioned now. It's how to operate it. Motors also are very important. What kind of efficiency of motors we use on those pumps. So IE5 now is available. That will also reduce the consumption of the pumps, and how we operate them. So first, we reduce the amount of water that needs to be transported by increasing the delta T to the maximum. And we know we're having problems of low delta T. So you need to design it and then install it, commission it properly, put the right valves, location of valves, so on and so forth. And then when you operate it, you need to operate it in a proper way. And this is where most of problems we face is during operation. And it goes to the balancing of the system. So normally the units that are closer to the pumps are getting more flow, and the ones that are not close to, let's say, the top floors are not getting enough flow. That is causing an increase of pumping to the above floors. When they get complaints, the BMS guy normally will increase the pumping because he doesn't know where the flow is needed. He knows that he's got a complaint, thinks maybe it's from the water, he increases the pump speed, then you have more water is going through the closer floors or closer units. That creates low density. You spend more power. So you need to look at the demand from a cooling perspective and from a hydraulic perspective. Because at the end of the day, if you require this amount of water to reach that point, you cannot go to the best efficiency point. You already lost it. Maybe sometimes, yes, you can have both requirements at the same time. So you need to balance the requirement in terms of cooling requirement at all points by having proper balancing, dynamic balancing happening all the time, and also by looking at the best efficiency point, see where to go with the pump to get which speed of the VFD to go to get to that best efficiency point.
So I think there's a common narrative that's emerging, that it's really down to how it's being operated. And Prabhakar, you want to comment?
Yeah, basically, as you said, the pump HP or the energy used is depending on the flow of water. And if the delta T is not improved, the Q will be very high. The formula for HP is WQH by 75 into efficiency. So the HP consumed will be much, much higher, to the tune of 35 to 50% higher if the delta T is not consumed. And the flow is directly proportional to the speed, and then it goes as the square root of the head and cube root of the pump power. So you can imagine if the flow is higher by that much, power is consumed is more. So you can optimize by controlling delta T in the system, and pump is not decided on the first index or second FCU. It is on the 2/3 of the index length. Basically, the pump head is calculated on the index. So in overall, it is the operation and delta T control is very important. And in a district cooling plant, hardly 3% of energy is contributed to the pump.
All right, thank you. Ibrahim, could I have you comment?
Thank you, Surendra, for the introduction. Yes, I agree with what Hassan was saying earlier, because if you go earlier to the point of the design, the selection of the system and the feasibility study you do at the beginning is one of the most important things, especially in district cooling, to select the system which will be designed. For example, in the DCP process, we have the chilled water and condenser water. The chilled water pumping arrangements could be divided into primary, secondary, or primary distributed secondary systems. When you go one by one for each and every system, the variable primary pumping option is usually designed in plants where the internal and external chilled water pressure drops are not high, so that the pump could be selected as a low voltage pump for feasibility. And it's also required that chillers can work on a variable flow condition. This type of pumping is usually designed in chiller plants where the thermal storage tanks are not provided, or if it will be required to be provided after, then you have to have a separate or a dedicated TES pumping or thermal energy storage pumping system to cater the tank capacity. If you go from this option to the other option of the primary secondary, which is mostly utilized in when the plant's capacity are higher, the chilled water network is longer, the chiller arranged in counter series flow. The primary pumps, we have two different pumps. The primary pumps will cater the internal DCP pressure drop, and the secondary pumps will handle the chilled water network. This is also to be sure that the pumps are within the low voltage selection. And when you add, it's easier to add a TES tank in this connection, because when you go for the secondary pumps, you can add the TES tank easily on the decoupler line, and you will include the TES tank capacity on the secondary pumps. The other option, which we don't find mostly we designed before, is the primary distributed secondary option. This is utilized when the development is bigger and the buildings will be built in phases with flexibility of the time and the capacity of the connected buildings. In this option specifically, the primary pumps are handling the pressure drop up to the chilled water network, and the distributed secondary pumps in each and every building will handle the flow from the chilled water network up to the ETS room, including the heat exchanger. If you go through the pros and cons of this option, you will find that the primary distributed secondary pumping scheme consumes less pumping energy than the other configurations. The pressure within the plant and the network will be less, which reduce also the network cost and gives you the flexibility of changing the rollout or the master plan of the development itself. We can say that also maintaining the control, the selection of the pumps, of the secondary pumps as a variable speed and varying the speed to maintain the required differential pressure across the building heat exchanger, and also maintaining control valve authority at its peak during partial load condition will increase the efficiency of the whole system. This is one. These are the common or the most used systems in the district cooling while you start the design of the system.
Mm-hmm. Thank you, Ibrahim. I'd like to bring Shekhar into the discussion. Maybe you can give us a contracting perspective. What have been the typical challenges? I mean, we've heard on energy efficiency. We have also touched briefly on reliability. And when we're talking about reliability of pumping systems from a hydronic balancing perspective, what have been the challenges as a contractor? You've had years and years of experience as a contractor in terms of district cooling. Could you share on this, please?
Sure. Hello, everyone, and good to catch up with you all. What I can see is that the pumping system is, in fact, the heart of the complete chilled water system or any other water distribution system within any property. So yes, whatever the designer or the consultant has done to the best of his intentions. So let's accept that when the project takes off, there are innumerable changes. There are a lot of other challenges which come into picture. And the engineering side, the contractor's responsibility is to ensure that all the elements are well integrated and well coordinated to ensure that the distribution, the pumping, okay, let's take the pumping system as the heart. The distribution takes care of that, and then the controls which are there are properly sized, the piping is properly sized, and overall the requirement is well understood. Yes, there will be definitely issues if you go on a copy and paste approach. Normally what happens is the designer or the consultant does give a lot of safety factor to the systems, keeping in mind the capital cost, and also in terms of keeping the budgets in mind. He ensures that it is done in the best of the interest of the project. But then it becomes responsibility of the contractor to ensure that it is properly engineered, sized, and then, as I said, is well, what do you call this, matched to the requirement. And also the other aspect, at least now, I think the items, the key items like the variable frequency drives, the controls, all of them have become very electronic and very, competitive. So on the price front, I don't see it as a big issue. So mainly the question of how much the contractor understands the requirement and takes into consideration all of these aspects. And in fact, any system which you are having a problem these days, and especially now that many of the buildings have aged or retrospect, now they've gone on a maintenance mode, you see that they are definitely struggling to keep up to the performance levels due to the shortcomings of the pumping system. So yes, as energy levels, it varies on a project to project basis. As what Mr. Nayak said on a DCP, it's hardly 3%. So it doesn't count as a running cost related. But again, it has a multiple effect in terms of performance of the overall system, right from the chiller power consumption to the airside power consumption, and overall to the comfort conditions or the required conditions within the building. So I believe definitely the contractor has a huge role to play in terms of ensuring that the selected system does its job. And yes, it's always good to have, as what one of the panelists was telling about, keeping it the right point. But always it is not practically possible. But I believe with the current systems in place, and also with what do you call this, with the well understood, I think the type of projects which have come up and the challenges faced. So I think it's not a huge thing in terms of sizing the pump set and making it operate to the best of its efficiency. One other aspect as a contractor I can see is that the motor and the pump relation. What happens is the motor, okay, I'm looking at the capital cost where the contractor tends to cut corners. So that is where it tends to compromise on the motor capacity. They tend to try to match the pump to the motor, and they leave a very little leverage in terms of any changes to the system requirement. And that is where it does affect the performance of the system as a total.
Thank you so much, Shekhar. Just a sub-issue, I'm just wondering, when you speak about all this, how has COVID affected everything in terms of it's really thrown occupancy profiles into a state of disarray. And I'm so curious to know how that is affecting the performance of pumps. Could I bring Anantaraman and then after that Anbu into the discussions, please? Maybe Anantaraman, would you like to comment? And Nimal after that, yes.
Yeah. It's a very interesting topic. When you ask about how the pumping efficiency is affected because of COVID, probably it could be because of part load, because most of the systems are operating in part load nowadays. So how the pumping system is being designed to cater these unforeseen events is a bit a tricky thing. Usually the pumps are all sized based on peak loads. And as Shekhar was mentioning, there is a lot of safety factor built in. However, I feel even though if the pump has been built with a lot of safety factor, we have VFDs where we can try to get the duty points to somewhere reasonable. However, data is the key here. So how the operator knows how to at which point you should run and on what basis. So on the secondary circuit, like cluster developments, we have n number of circuits where the index could keep changing, right? So we say, okay, this is the farthest distance. I have a X amount of load here, but even in one day time, the load shifts from one cluster to the other cluster, because sometimes the FNB on the other cluster, which is very nearby, it picks up. So the index on that circuit changes. So having one index circuit and then operating the pump pays to meet that one, sometimes may not meet the other circuit. So having multiple information gathered from the network is very important. So even in an event of COVID, where the part loads will happen on some sector of the clusters, but not on the other segments. So these information is key now. So data is essential. The number of index points cannot be just one. Probably it keeps varying in a project. So this have to be taken care.
Thank you. We shall be discussing data in a brief while. Anbu, could I have Anbu's comments, and then Nimal? And also I'm eager to hear from Sulaiman on the breed's response to COVID and how we are managing the profiles now. Anbu, could I have you speak, please?
Yeah. From the COVID perspective, a peculiar scenario which we have just faced is that in some buildings, which are like residential, I'm talking about, not the commercial sector, occupancy is now closer to 80%, 90%. You know, it's the other way, because earlier during July, August, people generally tend to travel, but now most of them are at home, and then even as a matter of fact, some of the complaints have started coming more this year because people are staying in the house, which is a very unusual scenario in Dubai. Yes, the pump selection, it all boils down to going back to the pump selection and appropriating the loads to the circuits in selecting the pumps. I'll take a step backwards. If you look at it 10 years, 15 years back, most of the systems were constant speed systems, very few variable speed pumping systems. The pump selection was a very, very critical scenario. You know, you need to just do the right calculations, the pump head calculations. Engineers had the time and then the mind to just do proper calculations and come up with even the index circuit selection or even the valve selections used to be absolute of paramount importance. And we used to spend a lot of time in going into it and selecting the right pump in terms of the heading, getting the right head and applying the diversities, which is for larger circuits. So we used to have the pump selected right. In spite of that, yes, there are certain safety factors and unknown elements and which you can't take into assumptions. So you used to have slightly maybe a larger pumps, which on site, most of the times the people, the good engineers on site also, they used to do the trimming of the impellers during commissioning and balancing because it was a very tedious process. This has changed in the, with the advent of the PACVs, the variable speed with the two-way valves and other things. Gradually, I can see that the shift in even the selection of the valves, control valves and the two-way valves modulating. So the risk is becoming a little bit lesser in terms of the selection process, and engineers do not pay enough attention into going in the right direction. And what they do, because most of their deficiencies corrected by VFDs. Because even if you select a larger pump, and yes, it is going to operate at not at the best efficiency point. Okay, fine. So if I select it by 10% or 20% sometimes, because plus in a place like Dubai, where people tend to go for an expansion in the near future, because you talk about hotel, because you start with something and then you always end up adding. So there is a certain parameter which is being considered as a safety in selecting the pump also. So if that doesn't happen, because this has happened in many of the, if you look at a lot of developments in Palm or many places, because you select a pump considering certain safety margins, but that doesn't exist.
No, I'm not.
So effectively what you have a pump which is much larger, particularly in DCPs. I think it is one of the major things. But limited developments, you don't have that kind of a problem. But these are generally left to the controls to do it, controls and VFDs to take care of it. And this is a major point, I would say, that is the reason for pumps not operating at their best efficiency. But nowadays, yes, the other control elements more and more are coming up, which I think in the subsequent points you may be taking it up, so you can cover it. So this is my take on the.
Sure, thank you. Nimal, could I have your comment? I think you're on mute, Nimal. Do you want to unmute, please?
Yeah, okay. Good afternoon, everybody. Other regions, good morning or good evening as it seems. Now, I'm not going to add on to anything what others have added this thing. I want to, especially on the variable speed pumping systems, something which I have figured out that for energy efficiency or to run in more energy efficient, having more pumps than less pumps is better. Say, for example, I have a chill water system, secondary chill water system, which is running with 3 pumps. But that same system, if I run 5 or 6 pumps, I can sequence it to run more efficiently on energy, especially because then how often does it run on full load? This is with this low load sequencing, this can happen. And I don't think anybody has looked at it very carefully. But when I do a design, sometimes I take into consideration, even the last design which I did, which is a current project, I have put more secondary pumps and more pumps on the variable speed missing than it was just normal required, not just 3 pumps.
Thank you. And I would like to hear from Sulaiman, your response, Tabreed's response to COVID and the changing occupancy profile. If you could please, Sulaiman.
Yeah. Before that, I would like to highlight something that we need to identify what is the main factor that affecting the pump efficiency and performance, and which is also reflect for the entire plant performance and efficiency. It is the only thing is the delta T, which is lead the operators or which is force the operator to run additional equipment and consume more power. And this scenario, it will increase the power.
Can you remove my name off your list, please?
Sorry,
Yeah, thank you.
1 second.
No, sorry?
Shekhar, could you please mute if you don't mind? Sorry, yes, please go ahead.
Yeah, it will increase the power consumption in the district cooling plant. So what we have to do to eliminate this factor, which is affecting the plant efficiency, which is the delta T. The delta T, it will start from the customer side, where the RCUs and the HUs. So as a technician or a facility management should look into the bypassing in the system, should close it completely, okay? To make sure there is no mixing water between the supply and retain, and which is also cause this bypass, it cause some short circuit in the network, and it lead or it will cause to bumping, higher bumping to satisfy the highest point. This is one point which is the bypass should be eliminated from the system. Second, we have to make sure that in the building side, the static pressure, it is maintained. And especially where we have the high-rise building, some of the company or contractor during the commissioning, they are not fill the system full of water. And the pressurization pump, it is small to top up to the end point. So if you want to make sure the system, it is pressurized with the static pressure and full of water, we need to stop the dynamic pump. Sorry. We need to stop the pump for around 5-10 minutes, and somebody he will put a pressure gauge in the top of the building, and he should find some pressure there around 1.5 bar. If there is some zero pressure, that means there is some air pocket in the system. Okay, this is the second factor that affecting the delta T and create some higher pumping to satisfy the entire system. Also another factor, it is the sometimes some building they keep some minimum closing for the two-way valve that to protect the system from the hammering. So this one should be eliminated because I am the end users. I get sufficient cool in my room. I have to switch off the blower. Once I switch off the blower, the valve it will remain open around 20%. Okay, that means there is some supply temperature which is 5 degrees or 4.5 degrees. Go across to the coil and go and mix with the retain, and this coil itself it will act as a bypass. And it will mix with the retain, and it will create also another short circuit, and we need to pump higher to make some higher pumping to satisfy the entire network. The facility management also should carry out a proper maintenance to clean the FCUs, the air filter, the strainers, etc. All of these points, if we are already eliminated from the system, that time we can establish or make sure that we will deliver a design retain temperature to delivery point where is the heat exchanger. And that time we can put an index point for the distribution pump or the secondary pump to control based on the index point. And we will make sure that every single end users and each FCUs, ASUs can get the sufficient cooling in the building with the proper retain temperature as per the design.
Thank you. Thank you so much, Sulaiman. You know, you spoke about FM and proper maintenance and so on. I just want to tie that with, you know, we are more and more hearing about digitally enabled, smarter and more intelligent controls for better pump performance. And I'm so curious to hear on Tabried's, you know, approach to this. And also I'd like to hear from Hassan on what Ashray is saying with regards to the new paradigm, which is being more and more adopted now. We're talking about more intelligent control systems for pumps and so on and so forth. So, Sulaiman, would you like to briefly continue, and then I have Hassan comment on that?
Sorry, I did not get the question, please.
No, I was asking, now we are seeing more and more application of digitally enabled, smarter and more intelligent control of pumping systems. What initiatives has Tabried taken in incorporating these for better performance of pumping systems in terms of, you know, to enable predictive maintenance and so on and so forth, and also remote monitoring? That's something that you have been doing. We in fact carried a news article on that.
Yes. And within Tabried now we are adopt to follow the remote control, remote monitoring and control, and we are in the project and discussion with all parties to run our plant unmanned operations. Okay, we will use the digital and the innovation as much as we can. We have also used the PI system. This PI system, it is a historian. We are collecting and gathering all the data from all the process, okay, and evaluate analysis, okay. We have a specialist team to do the analysis and give advice for the operators on the ground that if you run in this plant, in this philosophy, you can get or gain some saving on power or in dollar. We get a lot of innovation. We have also a business intelligence as a tableau. This tableau gives us a complete visibility for the system, how it is behaved, how it is working, and we have a PMT or excellence operation team. He can support. He's sitting in headquarters and he can monitor all the plants, around 20 plants for the time being out of 70 plants. They can monitor how the plant operated by the operation. They can give them a lot of advice, a lot of educating, how they can run the system in efficient and optimum points.
Thank you. Hassan, could we hear from you, the ASHRAE perspective on this?
Well, from ASHRAE's point of view, at least for this year, the theme from the new president, Chuck, is that the theme is called the ASHRAE Digital Lighthouse and Industry 4.0. And that's mainly focusing on the building industry by integrating industry segments and technology. So from an ASHRAE point of view, in terms of a general theme this year is to go more into digitalization and more into IoT. Now, looking at ASHRAE standards, you have some guidelines that have been published for the central plants that tells you what kind of sensors you need to put. And I've been working on many projects with district cooling providers in terms of unmanned machinery space or having kind of a learning system. So it's more intelligent controller that will understand what's happening and then upgrade or update the algorithm to match the requirements of the plant. So ASHRAE is also working on a set of guidelines for a standard sequence of operations. So currently there is guideline 36, which has mainly on the air side that, and the purpose of this guideline is basically instead of having to write every consultant to write these requirements in terms of sequence of operation and the specs, they can go to this guideline, select what kind of system applies to their own system, and then the suppliers can use that. Everyone, can just use that block instead of, reinventing the wheel. There's a new guideline that will come up that is focusing on chilled water plants so that it's more smooth. And one of the things that I've normally faced is that the system integrators are not really good in mechanical. They know how to control stuff or to build the control philosophy if you give them the right algorithms. Sometimes you just pick a block and put it on. It's an air handling unit, but it's actually controlling a fresh air handling unit. So they know how to program. They don't know the mechanical part. If we have such standards and guidelines, which is ASHRAE is trying to do now, it will be much helpful for the industry.
Mm-hmm. Thank you. In fact, about a month ago, we had an FM related discussion where we brought in the system integrators, and one of the key outcomes of that was there needs to be a two-way education of the mechanical engineers on one side and the system integrators, and there's a huge gap in that. And this is something that came across quite sharply. I'm curious to know how the scenario is in Saudi Arabia, Zakaria, in terms of uptake of smarter systems, more intelligent control systems for pumps. What are we hearing from Saudi Arabia on this?
The issue that we are facing here quite often is that there is a disconnect between the controls group and mechanical group. That disconnect is causing a lot of, you can say, lost opportunities, because sometimes the control system, the investment on the control system is heavy, and a lot of intelligent components are being implemented at site. But at the end of the day, the required functionality of the control system, whether it is a pumping system or any other system, the required functionality is not properly delivered. And that is due to lack of process understanding by the controls team or controls understanding by the process team. If the proper understanding of the process and the controls by both the team, if they come closer together, if control engineers become more of a, they start becoming more of a process engineer, and process engineers start becoming more of control engineers. If there is a good intersection between them, then probably the outcome will be much more significant and much more beneficial.
Thank you so much. Yeah, please go ahead.
The other point is sometimes the controls team, when they are implementing the project at site, the technician level people who are implementing the project at site, they are not familiar with their own system in the fullest extent. So whatever features that is available in their own control system, they are not able to deliver those functionalities at site. So all these shortcomings need to be addressed when we are talking about much more intelligent, artificial intelligent enabled machine learning type of control system. The skill level and understanding level of the control implementation team need to be enhanced much further.
So an integrated approach. I would like to move on to the next topic. We are quickly running out of time, but we still have two more important topics to cover. And I would like Ibrahim to comment, and also Anantaraman and Shekhar, if you could please. Over the years that we have covered pumping systems in Climate Control Middle East magazine, we have carried various debates on the wisdom in opting for a single sourcing of the pumping system. So does it make a significant difference if the pump, the controls, the sensors, and the variable frequency drives are sourced from a single manufacturer? Would that ensure, let's say, greater reliability, better energy efficiency, and greater scope for also overcoming the low delta T syndrome through this approach? Ibrahim, could you share your experience on this? And then I would like to hear from Anantaraman.
If you're speaking about how homogeneous the system will work, if it's from the same manufacturer or not, basically the control, it depends on the input and output points. For example, in the district cooling plants, most of the equipments now are running based on or utilizing a Modbus RTU or a Modbus system instead of having an input-output hardwire points, or both actually, but mostly the system is running based on this. So the thing is, which I ensure what Zakaria was saying, the involvement of the control specialist since the beginning of the project, since the designing, material selection, and understanding each and every material, the requirement of the process engineer, what's required.
Sorry, we're not able to hear you clearly. Could you repeat, please?
To be monitored, what's required to be controlled. What I was saying is the integration of, or the involvement of the control and instrumentation engineer from the design stage to the material selection, understanding each and every material, what's the requirement of the process engineer, what's needed to be monitored, what's needed to be controlled at each and every material, and then the execution of the same will ensure this homogeneous between the equipment itself. It doesn't have to be the same manufacturer, but the systems itself has to be integrated together, has to be selected properly so that it works together. This is one of the points which was Reddy was talking about earlier, that in the designs you have a lot of safety factors. The thing is that when you see it as a safety factor, we as designers see it as involvement of each and every manufacturer in the market. So when we do designs, we do design which is suitable for involving each and every manufacturer in the market. And then after this, the post tender or the construction stage, at the beginning of it, the engineering team of the contractor along with the supervision consultant will have to work together so that each and every selected equipment to be verifying all the data, all the capacities, all the loads again, and ensure that the selected systems are optimized or are optimum system. This is one of the major important things which we were discussing earlier, which Reddy was discussing.
Sure. Okay. Thank you, Anantaraman. Would you like to comment on this, please?
Yes, sure. As a consultant, single source is a bit of a tricky thing for us because the client requires open source and the contractor can get the best price. So this is where we are stuck up. However, we know the pump manufacturers, they know the pump curve better. They know where to operate the pump much better than the controls, because there is less amount of transparency. The pump manufacturers, if they can digitize most of their systems, pump curves and everything, and then provide a transparent information to the buildings controls BMS, so it will be easy for them to integrate the system as a whole, because BMS will integrate chillers, they will integrate cooling towers, they will integrate so many things. So if the pump manufacturers can make all the graphs more performance points and everything more open protocol, I mean, more transparent, and then educate the BMS specialist, it will be very simple. Smaller systems, smaller buildings like simple air-cooled chillers with primary variable pumps, definitely yes, it could be single source, and then the pump manufacturer can integrate all the controllers. In fact, nowadays they come up and there is no need for a delta T index circuits, because they can very well measure the pump ampere based, and then they can see what is the based on the so they can very well fine tune it. So small projects it's fine, big projects they need to be more transparent, integrate with the BMS controllers. Yeah.
Sure, thank you so much. Nimal, yes.
I agree with what the last person was saying, because I find that having the pump, the speed control, the VFD, and the pump control panel from the same manufacturer very advantageous. Especially with the new pump, some of the pump manufacturers integrate part of the pump curve into the VFD, so that they know how the pump works when they look at this thing. So that way you can get very energy efficient operations.
Okay, Prabhakar and Shekhar, could you quickly comment? We are running a bit out of time, but if I can have Prabhakar go first, please. If you can unmute, please.
We talked about efficiency and other things, but we have not addressed on type of pumps being used: horizontal split casing and end suction pumps, long couple, short couple. So if it is large capacity pumps, more than say 100 kilowatt, we go for horizontal split case pumps, so that the load of the impeller is supported like a simple supported beam, which is more efficient, easy to maintain and things. And every component in a system is contributed to the pump efficiency, because even the friction of the pipe affects the head on the pump, like 4 FLV square by 2 ZD. So the F has to be as low as possible. The pipe material, the wall material, the cooling coil pressure drop, everything adds to the system efficiency or the pump efficiency. Thank you.
Thank you so much. Yes, we meant to discuss about horizontal and vertical, but in the interest of time, we had to perhaps move quickly. Shekhar, could you please comment?
Okay. Totally don't agree with Mr. Nimal's comment, because the flexibility should be there in terms of the hydraulic system as well as the controls. Now, see, the main aspect here is, I think the guy who's handling the hydraulic side, who understands the system, takes the lead, and the controls has to follow that. Because what happens is, the person on field understands the system better than the guy who does the controls, because his understanding of the system is limited. He is just concentrating on his elements, how they interact with the respective, pumping systems or whatsoever they're trying to control. So I believe that it need not be from the same source. Definitely not. I've done many projects, and it gives flexibility in terms of both pricing as well as functionality perspective in terms of sourcing and other things. And number two, very important, is that the guy who understands hydraulics is very important to ensure that the pumping system does operate optimally, and the controls person supports the hydraulics requirement. That's my take on it.
Thank you so much. I had one more issue briefly I wanted to discuss, because this is something that perhaps we need to bring the consultants into the discussion, which has to do with oversizing the pumps in a system, and what are the implications, the effects. If we could get a quick 10-second comment from, or 15-second comment from each of you. Nimal, you want to talk about it briefly? We're really running out of time, and maybe we also have a couple of questions from the audience that I would like to quickly bring in.
In fact, I have a complete PowerPoint presentation regarding that, but we don't have time. Oversizing of pumps is a no-no, because it's not only the energy, the life of the pump is also reduced. Because when you oversize, it goes out of its best operating point. And either way, if it is, see, most of the time people oversize because they add 10%, 5% to the head, 10%, 5% to the flow, and then you have a pump which is oversized. It is not operating at its best. There are a few things that happen. One, the pump can cavitate, and also there is vibration. Then if you go to look at the motor is not operating at its efficient point. It's at a lower load. You can see that the power factor increases and the load increases. So it's not only the life of the pump, but the energy is also higher by oversizing.
Thank you so much. I'm just going to take some questions that have come from the members of the audience. And this question is coming from Haris Qureshi. And he says, there are a lot of existing building stock that does not have PICV. So the pump control is not working properly. Nowadays, the PICV are even being replaced with energy valves, which are providing even better control, which information feedback is being provided. Once a system knows its own operating point, it can offer more control and can be more energy efficient. So what does the panel, how does the panel see this, the adoption of IoT in the hydraulic market? Would anyone like to comment on this? Maybe a show of hands. Anbu, yes, please go ahead.
I think we have been doing a few energy audits in the past as well as in the recent past. Most of the buildings, they do have either three-way valves with constant speed pumps, which can comfortably be changed to two-way valves, which we have done in a retrofit for a large hotel cum residence building, and there was a very good energy saving. So PACV has come, which is even better in terms of balancing and energy saving. So
sorry, getting a bit of disturbance. Yeah, please go ahead.
Yeah. So it's a very much it's possible for retrofits, the changing from three-way or two-way conventional valves into PACVs, and which if it can communicate. But the problem is most of these buildings, even the BMS, if you look at it 10 years, 15 years old buildings, absolutely all the components are outdated. The retrofit can be more tedious. You need to change a lot more, and the cost, depending upon the life of the building, what it is going to serve, that can be the decision making. It's the economics, more to do with, so going for IoT, going for the trending technologies, I would rather say that rather limited for retrofits because of the integration with the existing BMS or the control system. That can be the limiting factor.
Okay, thank you. This is coming from Ibrahim, and it's more of a comment. I think it responds to the last topic on oversizing of pumps, and he says, all of us agree that inefficient system operation can be caused by a number of problems such as improper pump selection, poor system design, excessive wear ring clearances, and wasteful flow control practices. Indications of inefficient system operation include high energy costs, excessive noise in the pipes and across valves, and high maintenance requirements. I don't know if any of you would like to, I was just reading that as a comment. I'm just scrolling down. And there's one more. This has come from Masood Rasa, and he says, considering oversizing of pumps, would you suggest to install VFD on primary chilled water pumps? The chilled water circuit consists of constant primary and variable secondary. So that is something that Masood Rasa has posted. And
We need an answer.
yes.
So yeah,
and there's a question coming from an anonymous attendee, and he says, what are your thoughts? What are the thoughts of the panel on prefabricated HVAC pump skid systems? Today, all pressure boosting systems are specified as prefabricated systems to ensure single source plug and pump operation. However, HVAC systems, which are much more critical, face higher coordination issues, are still acceptable with equipment from 5 different manufacturers. Would you like to comment on this, any of you?
you want me to take the first question on the?
Sure.
Yeah. So the question, I believe, came from
Masood.
Yes. So the primary pumps, if let's say you find the primary pumps are oversized, so you might need to add a VFD just to reduce the, instead of like say trimming the impeller. In some projects we're working on, even on district cooling plants, we've added VFDs on the primary pumps, and they're being controlled with an advanced control system to modify the primary pumps to also gain some energy reduction from that as well. So yes, you could. Sometimes you might not feel the urge to do that because the savings are not that much, but we've done it especially on bigger plants, and we've seen savings. So the new, let's say, designs is VFDs everywhere, condenser pumps, primary pumps. Well, I've seen it in some cases where the pumps is oversized, the throttling valves or the on-off valves have been throttled down to maybe 70% in some cases, just to get to that system curve. And then in that case, putting a VFD on it and opening the valve will reduce a lot of pressure on it and will reduce the energy consumption. Now, I also wanted to add here is that the plants that I've worked on, especially the cooling plants, the consumption of pumps was higher than 3% that was mentioned earlier. So it's more than 3%. I've seen cases where it goes up even to 10 and 15% when we have low delta T. Because of the requirement when you have low delta T, you need more pumping compared to the chilled water. So in general, it's more than 3%. If it was less than 3%, we wouldn't be like that bothered about pumps. But I've seen it in general more than that.
Mm-hmm. Quite worrying, yeah. And the other question, for the benefit of everyone, I'm just going to quickly read that. What are your thoughts on prefabricated HVAC pump skid systems? Today, all pressure boosting systems are specified as prefabricated systems to ensure single source plug and pump operation. However, HVAC systems, which are much more critical, face higher coordination issues, are still acceptable with equipment from 5 different manufacturers. I don't know, maybe we just treat it as a comment. Anbu, Zakaria, yes, quickly, if you could, please.
Actually, if you talk about prefabricated pumping system, that could fit in some situations of projects where the space is of a big constraint. If there is a compact space requirement and a pumping system need to be implemented there, probably a pre-engineered, prefabricated pumping system can be considered. But in other cases, if it is a built plant, then probably we have lots of flexibility with selecting appropriate pumps, integrating different components from different manufacturers with the transparency between open protocols. We can go for those kind of applications.
Okay, thank you. Yes, Anbu.
Yeah, in a recent project, the contractor had proposed the prefabricated skid. The entire pump room has been prefabricated in off-site, and it has been just brought and installed at site on the roof. So absolutely, it was these are the things which are developing even in the construction industry. If you look at the BIM, which is being implemented on the contractors level from beyond 500, even the contractors, they have their own BIM systems in which the coordination is done to the perfection. So everything is done off-site. All they do is they bring it and then install it. It just took a couple of days or something. So if it had been done on site, it would have taken much more time and the complication, you know, because so many people standing on site and working all at a time. And the time required also, it would have been much more. So it was a very wise decision by the contractor to propose this. And now we do seriously think that it could be a good option. It's not like a one single source, somebody's it's not the pump manufacturer who's going to do this work. It is a contractor with all the coordination which is done in terms of the shop drawings. It goes back. So it's a good engineering practice. And if it is implemented right, it's really, and we found it to be very, very good on site. So that's a comment. I mean, we can say that, yes, it is a
sure.
to the future.
I'd like to end with Sulaiman to give us a district cooling utility perspective on this topic. Single sourcing, if you could, Sulaiman, and then we'll have to conclude the plenary. You are on mute, Sulaiman. If you,
yes. As they mentioned, my colleague, that the single sourcing, it will lose you the competition for the material. I will give you some limitation to select the equipment to go with the higher efficiency. And I did not see any problem if I can select the instrument from manufacturer and the pump or VFD from the other manufacturer. We have here within Proleed a lot of cases in this scenario. And even sometimes I have a different chiller within one plant, and I did not see any restriction or any limitation for me to run the plant efficient. Most of my plant is running within the design criteria and better. It's around, we have this year we achieve around 0.89 or 8 kilowatt per ton for the entire plant, which is I did not see any problem with if we go with the different or several manufacturer to select our equipments.
Thank you so much. And much as we wish we could continue this discussion, we have to end it. I would say thank you so much, every one of you, for giving your time and your valuable insights. Really do appreciate it. On this note, it is now I have to pass on the microphone to my colleague, Frederick Paye, who is the co-founder and commercial director of CPI Industry, to take us through the sponsor recognition ceremony and the vote of thanks. Thank you, all of you, for participating from my side. Thank you. Yes, Frederick.
Thank you very much, Randall, and hello to all of you. Thank you for joining today on this very focused webinar on pumping systems and sharing your insights and experience. It is my pleasure to see at least some of you today. And so I would like to proceed with the ceremony, if you allow me. And I would like to remind you that today's session, live session, is only the tip of the iceberg, as this very webinar has been recorded and shall be broadcast to all our social media platforms, websites, as well as YouTube channels to allow the entire global readership of the magazine to take part, to partake of it. And it will obviously be covered in the upcoming issue of the printed and digital editions of Climate Control Middle East magazine. So thank you very much to all of you, our distinguished panel of speakers and sponsors and partners, for taking part today. I would like first and foremost to thank our panel sponsor, Proleed. Thank you for your support. And I would like personally to thank Mr. Sulaiman for bringing, very valuable, hands-on and practical end user experience to this discussion, and I'm sure you all will benefit from that. I would like to thank our strategic knowledge partner, Allied Consultants, as well as Griffin, GRFN, and Lexander, I hope I'm pronouncing it correctly, as well as Proleed, and at last but not least, Protect Cooling, Shuemi, Design based in Saudi Arabia, as well as our strategic HVAC recruitment partner, carriersbay.com. And now, if you allow me, I would like to take you through the various digital platforms, apart from the printed edition, of course, that we have and that have been recording, an uptake in recent times due to the pandemic situation. I'm sure you must all be familiar with our main website, which is news-driven, climatecontrolme.com. And we recently launched last year a global platform for the HVAC industry, segregated into geographical areas, entitled climatecontroljournal.com. So we welcome you, obviously, to visit them on a regular basis. As some of you may be already aware, we are happily celebrating, although in a more confined manner, I would say, our 15th anniversary of existence of the magazine and the company. And I am taking you through here a sample of our digital issues. All our back issues are available online on our main website. So you can browse for free, all the magazines since 2006 at your leisure. And I can safely say that what has made the success of the publication is truly the pertinence, objectivity, and neutrality of the editorial coverage. And you have here on the screen some samples that exemplify that. Here, an interview with the HRI president, Mr. Steve Jurek, and some more recent excerpts as well of articles in the magazine. Obviously, the COVID-19 has taken a lot of space in our publications for obvious reasons in terms of IAQ focus and so on. And at last but not least, we also have our print and digital platforms for our guides and directories, which are very popular. We have the Climate Control Guide and Directory, climatecontroldirectory.com, as well as Refrigeration Buyer's Guide, also available online, which will be launched at the physical exhibition, again in the Trade Center in Dubai in November. Gulf Food Manufacturing, hopefully we shall take place in November. And now I would like to take you through our upcoming webinars as well. We have in 9 days, on the 19th of August, a very interesting one on vaccines, conservation, transportation, and cold storage, chaired by Dr. Toby Peters he was a professor of coal economy at the University of Birmingham in the UK, very prominent speaker, so we invite you to join that as well. As well, on the 1st and 2nd of September, our first virtual HVACR exhibition series, IAQ Strategies and Solutions, which will also be unveiling a new profile section on the champions of the COVID fight. So companies which have particular solutions to fight the pandemic from an IAQ perspective will have the opportunity to profile themselves in that profile track. More details at your disposal. On October now, hopefully also as a physical event, as we've just received the latest directives from the government to resume conferences in hotels and in physical venues. So the Client Consultant Contractor Conference 4th edition shall be hopefully taking place on October 2020 with a co-located event on IT and HVAC, a very much trending topic. And should not that be the case, we obviously urge you to constantly monitor our website, cpiwebinars.com, for the latest information and updates on our events, as some of them may be converted, for various reasons, to online events. And we shall be concluding the year with our 10th, again, another anniversary, Annual Climate Control Awards, our landmark event, which will happen hopefully as a physical event on the 24th of November, which is sponsored so far by Leminar Global and REAM. And I forgot to add as well that our bronze sponsor currently for the Climate Consultant Contractor Conference is Mecca, Samsung, and Royal Gulf as well. So thank you very much for your attention and for joining in today. and look forward to seeing you in person very, very shortly indeed. Thank you very much, Surendra.
Thank you all. And with that, we conclude this webinar. Look forward to meeting you again very soon. Thank you, all of you.
Thank you. Thank you, Jensen.